Okay, here's your first makeup assignment. It says a bank account contains $5,000 and earns 3% interest per year. How many years will it take the account to reach $6,000? So you're solving for the years, and you got 2 units. You're going to have to just write the 2 units. You have years, obviously, because that's your answer to the problem, and you've also got dollars. Those are your 2 units. So X is years, Y is money in this equation. So per dollars per year, we don't really have a dollars per year because it's a percent per year. So it's plus 3%. Interest is, and it doesn't say compounded, so you don't use that big formula that I still have on the board after the 3-week period. I haven't erased it yet. Okay, so then if it's a percent increase and not a dollar increase, that means it's not a linear equation. You're not going to draw a line. It's not linear. It's an exponential equation. That means it would be the initial amount would be repeatedly multiplied over and over and over. So use this equation: a times b to the x power equals y. Now here's what a, b, x, and y stand for. A and y stand for the same unit. Since y is dollars, then dollars is y, and dollars is also going to be a. Okay. Now you have $2 amounts. Your A is the initial amount, 5,000, and your Y is where it wants to end at, which is 6,000. Now your B is your percentage growth factor, or it could be a decay factor. This is growth because it's plus 3%. You need to take 100% plus 3%, and that's 103%. Okay, so B is 1.03, and then X is what we're trying to solve for because X is the years, and we don't have that, so question mark. So write out the equation. You got 5,000, and you'd be multiplying that by 1.03 to the X power equals 6,000. Now you're solving for X, but X is a power, so you want to parenthesize the power of X and the base of the power 1.03. Now, before you worry about this, you need to cancel out the multiplication of 5,000, which we would do by dividing by 5,000. That's going to be 1.03 to the x power. And then 6,000 divided by 5,000 is 1.2. Okay, now you use your COB, your change of base formula, because you're never going to be able to multiply 1.03 till it hits 1.2. So X is equal to log over log, and you put your 1.03 on the bottom and your 1.2 on the top. Okay, then you take a calculator, you go log 1.2 divided by log 1.03. And that would be, it would be 7 years, 7 full years till you're at 6,000. Just put 7. So that's the answer, 7 years. Okay, example 2. In the year 2000, the average price of a football ticket was $50. Tickets are increasing by an average of 6% per year, not $6, 6%. How many years does it take the price of a ticket to reach $75? Okay, so we got dollars and years. X is years, Y is dollars, so per. Dollars per year. Again, you don't have a dollars per year increase. Instead, you have an increase of a percentage. It's 6%, so plus 6%. Okay, so again, I use my exponential growth decay formula. Y equals A times B to the X power equals Y. So A, B, X, and Y. So again, A and Y stand for the same thing, dollars. Okay, so A is where the dollars started at, which we know is $50, and Y is where they ended at, which is $75. Okay, B is your growth factor, your percentage, but you got to take 100% plus 6%. That's 106%. So move the decimal twice, you got 1.06. Okay, X is your years, which we don't know, question mark. So I set up my formula. I got 50 times 1.06 to the X power equals 75. So again, solving for the exponent, we do it the same way we did the last time. We got to cancel out this multiplication of 50 before I worry about anything else. 75 divided by 50 is 1.5. Then X equals log over log. So 1.06 goes on bottom. It has to, the base of the X has to go on the bottom, and then the product 1.5 goes on top. Then I take log 1.5 divided by log 1.06, and I get, that's a 7 again. So the years equals 7 years. Okay, example 3. A new car is purchased for $16,000. The car declines in value by 10% per year. Find how many years it takes a car to get down to a value of 15. Wait a second, it's supposed to be 5,000. Okay. Okay, so again, you're solving for the years. How long means solve for the years. Okay, so you have years in dollars. Years is X, dollars is Y, and then per year. First, it's not dollars per year, but it's percent. So it's minus 10% because it decreases. So that's now called the decay factor, but the equation is set up the exact same way, whether it's growth or decay. Okay, A and Y stand for the same thing. Well, over here, Y is dollars, so A has to be dollars. So the dollars start at 16,000, they end at 5,000, which makes sense that where the B is going to be a decay percentage. It means it's less than 1. So I take 100%, but this time I'm minus 10%, and that's 90%. So you can write 0.9 or 0.90, it doesn't matter. And then X is what we don't know. So the equation now is 16,000 times 0.9 to the X power equals Y, which is 5,000. Okay, so we divide by 16,000. Okay, 0.9 to the X power. And 5,000 divided by 16,000 is 0.3125. Okay, so set your X equal to the log over log. 0.9 is on the bottom, 0.3125 on the top. Okay, I got 11, so 12 years, go 12 years. If it's over 11, that means 11 is not enough, it gets 12 years. Okay, example 4, now things are going to change. I put $14,000 in a bank account. The bank account, sorry, I mistyped that. The bank account increases by a constant percent each year. In 10 years, the account's worth $23,011. Find the interest rate on the deposit. So interest rate means you're finding the percentage, okay? That's what you don't know. So what are your two labels? Well, you got dollars and years again. So years is X, dollars is Y, dollars per year. Okay, there's no dollars per year, it's a percent per year, but the percent is unknown. When the percent's unknown, you're going to label that B, because you don't know the B. But I still use my same equation in A, B, X, and Y. Okay, A and Y stand for the same thing. Okay, it's going to start at 14,000, and then it ends up at 23,011. And then B, you don't know this, okay, because you don't know your growth or decay. It'd be a growth factor, but you don't know it. And X is the years, which we know is, we know the years. We have 10 years, okay? So the years, X equals 10, so plug them in. So we got 14,000 times B to the 10th power equals 23,011. Okay, then divide. Okay, you're not going to use log over log because you know your power's 10. Okay, you're not figuring out the power. You're going to divide by 14,000. And then you're going to find, and then you're going to put a radical on both sides to cancel out the 10th power. Okay. So 23,011 divided by 14,000 is 1.64. Now, the 10th power, like I do with the second power, I do a square root. When I have a 10th power, I'm going to make a 10th root. And hopefully you got one of these calculators. I think you always did, okay? You're going to type in 10 second caret 1.64. Now, you just about got it. Put 1.05. But there's two things you have to do now. You need to always subtract 1, and that's 0.05. Now trace the decimal 2 forward, and you have 5%. So it's a 5% rate of change. Okay, example 5. A new snowmobile costs $5,000. The value of the snowmobile decreases at a constant percent each year. After 3 years, the snowmobile is worth $3,061. Calculate the depreciation rate. So, depreciation means it's a decay factor. And you've got dollars and years. So years is X, dollars is Y, so it'd be per dollars per year. Okay, but it's not a dollars per year, it's a percent per year, but that percent is unknown. So A times B to the X power equals Y. A, B, X, and Y. A and Y are the same thing. They both be dollars. B is a percentage. X is years. Okay, so dollars, well, they starts at $5,000. And it goes down to 3,061. This is what I don't know, question mark on the B. And then the years, we have 3. So we're going to have 5,000 for A times B to the 3rd power equals 3,061. Now, all you got to do is divide and then find the cubed root of whatever that quotient is on the other side. 0.6122. Okay, so I go 3 second caret to get the cubed root. 0.85. Now, yes, you're going to subtract 1, and that takes you to negative 0.15. Trace the decimal forward, and that's 15%, okay? Negative 15% because it's a decrease. Okay, last one in this video, and I'll make another one for you. Your new computer costs $22,600. The value decreases by a constant percent each year. After 5 years, the computer is worth $1,154. Calculate the depreciation rate. So you got dollars and years again. On number 1 on the assignment, it's not dollars and years, it's people and years. Just you're smart enough to figure. You're pretty smart, though, to figure that out. So dollars per year. It's percent per year, which we don't know. That's the answer to the problem. So A times B to the X power equals Y. So by now I think we figured it out that A and Y both stand for dollars. So it starts at 2,600, it ends at 1154, so it's going to be 2,600 times B to the 5th power equals 1154. .44. Okay, so I find the fifth root. Okay, and I get 0. This is going to be it's going to be the same thing as last problem. 0.85 minus your 1, and that's negative 15%. So negative 15%. Okay. Okay. There's another doc I've shared with you, and that'll cover the next one.